Okay, I just looked at it. This 3 is what the first term would have been had I not started at 2. 5 is a common ratio, and n minus 1 is the number of terms I have minus 1. So let's figure out how many terms I have. That's n total. So n is, I start with my top number, 7 minus 2 plus 1, that's 6. The way that I think about that is if I start at 5, this is an easier picture for us to picture. How many numbers are in between 5 and 3, including 5 and 3? And I can't just do 5 minus 3, that's 2, because I have to include 3, 4, and 5. So I do 5 minus 3 plus 1. So there's 3 terms total, 3, 4, and 5. Okay, the first term, when I count n as 2, I just plug in. I plug 2 in here. So 3 times 5 to the 2 minus 1 power is 15. And then my common ratio is listed right here. That's 5. Then I just plug that into the second formula. My first term, when I count n is equal to 2, is 15. 1 minus 5. How many terms are there? There's 6 terms. So 5 to the 6th over 1 minus 5. I can rock and roll here, and I see that my answer is going to be huge. It's going to be really, really huge. So S, the sum of the first 6 terms is 58,590. Okay, let's keep moving. Now we're going to learn how to take the sum of an infinite number of terms in a geometric sequence, and that's called an infinite geometric series. The common ratio in this case must be, the absolute value of the common ratio must be less than 1. Otherwise, the series is divergent. And what that means is if it keeps growing, if it's like 1, 2, 4, 8, 16, 32, if I add up all these, we can see very clearly it's going to go towards infinity. 1 plus 2 is 3, 3 plus 4 is 7, 4 plus 8, or 7 plus 8 is 15. Where am I at? 8 plus 16, or 15 plus 16 is 31, 31 plus 32, 63, and it's going to get really huge really quickly. So the sum of all these values is not going to converge on a single value unless my common ratio, the absolute value of it, is below 1. The formula for adding up an infinite number of terms is actually shockingly easy. And this works, in this case, and in Calculus 2 in college, you'll discover that there are even better ways to do this. So we're going to find the sum of an infinite geometric series when my first 3 terms are known, 9, 3, 1. Obviously, my common ratio is 1/3. So my sum is the first term over 1 minus 1/3, that's 2/3. So 9 over 2/3, flip the negative, that's 27 over 2, that's 13.5, as you can see here. With sigma notation, you can see this is my last term. I'm going to infinite terms. I'm going to start at n equals 4. And then 4 would have been my first term had I started at n equals 1. 0.2 is my common ratio, and n minus 1 is always there. So I figure out what the first term is actually. So I plug 4 in for n. So 4 times 0.2 to the 3rd power is 0.032. Then I plug that into this formula. 0.032 is my first term, 1 minus 0.2, and that is 0.04. Hope you all are having a great day. I'll talk to you later. Bye.